Welcome back, my virtual mathematicians. Today we're going to be reviewing some of the concepts we've been covering this week, and we're going to give you a taste of what it looks like when we put them into word problems. So as we go through the problems, I'll be kind of talking about them, showing you my thinking by my talking, and then the video will pause and you'll get an opportunity to answer the question. And then I'll pop back in and check to see how well you did. So that being said, you're going to need some paper and pencil. And in order to tackle this job, we always want to be writing our thoughts out. So pause the video, run and quickly grab yourself some paper and pencil. Please don't use toilet paper as it tears. And I'll be playing some elevator music while we wait. And welcome back. All right, our problem number one has to do with Carrie, and Carrie's going to compare decimals representing models. So as you can see, we've compared the decimals before, but this is a picture form of comparing them. First thing I notice when I look at this is I have one model that's broken into 100 pieces, so that's got to be my 100th spot. And I've got another model broken into tens. So that's going to be my tenths. So which symbol should she write in the circle to compare, to make it correct? Make it correct. And we're going to go ahead and pause the video and let you guys look at that quickly. All right, let's check your answer. So I know that even though there are 100 pieces, each piece is worth 10. That means I've got 10, 20, 1. So if I were to go ahead and grab my pen over here, and I'll use my calligraphy pen, and I would put 21, and since it's not a whole, it's part, I have to put 21 hundredths. This one is 2 base 10 bars, so that would just be decimal 20. There we go. That means the alligator is going to eat the larger piece. I've got a greater than sign, which tells me D is the answer. I hope that you got that one correctly. All right, let's look at question number 2. Harriet drew the models below to represent 4 different decimal numbers. Which list shows these decimal numbers in order from least to greatest? All right, first thing I would do is I would write each one of these out to determine that. Okay, so I'm going to calculate. Remember, when we're figuring these models out and there's shaded areas, we look at the shaded portion. So I've got full bars here, so I can count these by 10, 10, 20, 30, 40. So I'm going to put, since they're all a hundredth place mark, I'm going to put, remember my decimal line. My first number was 4, and then the piece, the half one, 1, 2, 3, 4, 5, 6. Okay, there we go. This one here, decimal, it's a hundredths plate, line, so tens, hundreds. I've got 10, 20, 30, 40 again. And then I've got 1, 2, 3, 4, 5, 6, 7. I notice when even comparing these two, this one's greater. This one here, decimal, line. Teachers love it when you show your work like this. 1, 2, 3, 4, again, 4 tenths. And looks like just 2 in my hundredths. And decimal, I've got another 100 spot, line, 10, 20, 30, 40, 4 tens or 40, and 1, 2, 3, 4, 5. Okay, now that I've written them out, and I remember I want least to greatest. So I want my smallest first, so I don't have to look at my 10 spot because, well, that doesn't work because they're all 4s. So I'm going to look at my 100th spot and I'm going to find the least one, and then I'm going to go greater than that. Go ahead. Video's about to pause, so choose your answer now. Welcome back. Look at here. I've got 2, 5, 6, 7. So any of those that look like that, 2, 5, 6, 7. Ah, look what happened. Notice my calculations were just a tad bit off, as I don't have all these answers. One of these was 4. Which one did I get? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Wow! I did that for a reason. Do you know that sometimes they're going to put down here the answer choices that aren't there? So how many times would boys and girls just go down here and look for the smallest, the least, and work to the greatest and choose it when a picture wasn't provided? Boys and girls, you always want to use what they've given you, provide a breakdown of what they've given you in number form, and then go down and search. So the answer for this has to be C. I tried to trick you. Don't let them ever trick you. You got to be smarter than them. All right, let's go to our next question here. Oh, we've got 2 of them here. Question starts out as, which model represents a decimal number that is greater than 2 and 2/10, but less than 2 and 2/5? Well, if I'm going to figure this out, I'm probably going to build me a number line, okay? And I know some people don't like number lines, but you know, when we're comparing things, it's just a little bit easier. Now, look at my whole numbers. It's 2 and 2, right? So that tells me that on one end of my number line is going to be 2, the whole number, and the other end of my number line will be 3, the next whole number, because 2/10 and 5/10 is in between that. So then my hash marks, I know, since this is 10/10 here, I can break it into 10 pieces and it'll automatically. So let's get that. So there's 5, 4, 3, 2, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So let's look at A. A has, well, we've got 2 whole ones, and then we've got 2 short whole ones, so 2, that would be 8. So this A is here. Wait, this was 0.05, right? Or 0.5, I should, sorry. 0.5, okay? 0.5 there. So A would have to be 5, 6, 7, 8. This would be A. All right, I'm plotting it, I'm just marking it. B would have to be 2 whole ones, and then there's just 2 colors, so 2 and 2/10. This would be B. I'm plotting that on my number line. And then C looks like it's 2 with 3/10. So No, that's 1/10, 2/10, 3/10. So this has to be C. There's my whole 2. There's my 3/10. 1, 2, 3. Oh, I'm missing 4, aren't I? Sorry about that. 4, 5, 6, 7, 8. There we go. And then D would have to be 2. There's my 2. And then 1, 2, 3, 4, 5/10. Okay. All right, go ahead and pause the video. See if you can figure this one out. Welcome back. Surely, in order for mine, it has to be greater than 2.2. So my 2.2 mark is right here, right? And B cannot be it because it's not greater than. It's exactly 2.2. D cannot be it because that's not less than 2.5. It's exactly 2.5. So my answer has to be C. All right, let's go on to the next question here. It says Marcus, he drew this model below to represent 4 different decimal numbers. So our goal here, to figure out those decimals. Padre, let's do it. My first one is 100ths, broken into 100 pieces, so I'm going to put decimal, line, okay? 2 places. I know I've got 1, 10, 20, 30, 40 tenths. Okay, that's good. And then my singles, my units are 1, 2, 3, so I've got 300ths. Number 2, it's using full tenths. Okay, it's broken into tenths, so I'm just going to put decimal and 1 line for the tenths. When I count my tenths that are all filled in, because we always count the shredded part, it is a 3. Number 3, again, I'm just working with full tenths, so I just need 1 line past my decimal, and I've got 1, 2, 3, 4. And then my number 4, it's broken into 100 pieces, so I need 2 lines, 1 for tenths, 1 for hundredths. How many tenths do I have that are filled up? 1, 2, 3, and we're going with 3. And my next one is 1 short of a full one, so it'd be 9. I'm done. Okay, hopefully you got that one correctly. Let's move on. This one says, which model shows 23/9 decomposed into a sum of fractions? That's pretty much how I feel about this question. I'm so confused. Does anybody notice what I see? First of all, we've got some large vocabulary. We got that word decomposed. Decompose, I know when something goes into the ground, it decomposes, and it means it breaks down into smaller pieces. Same goes through with my fractions. But I'm confused. Usually, my parts of a whole are smaller than my whole piece. So let's think for a second. If by any chance, if you can have a numerator bigger than its denominator, think about it. Well, you can. And this is what you call a number that has a numerator bigger than its denominator. Let me show you something. So if we have 23/9, okay? First of all, you got to ask yourself, how many ninths Like how many make a whole? If you count these up, 1, 2, 3, 4, 5, 6, 9 shaded over 9 total pieces equals 1 whole, right? That equals 1 whole. So if I take 9 pieces away from that 23, let me grab my eraser. And now I've got, quickly do the math, 14 left, right? Because right now I've got 1, and then I've got 14 over 9. Now, 14 is still larger than 9, so I can take another 9 out, can't I? So if I remove another 9 out of here, I'm down to 5. Oops. 5/9. And of course, I'm going to change this to now 2, because I've taken 2 out of there. All right. So, cross that off. I can just erase that because I was just showing you that 9 9s make 1, and we were able to take 2 of those 9s out of there. So now, if I've taken 2 and I have 5 left of my 9 that are still shaded, that is called a mixed number. 2 wholes and then 5 shaded out of the 9 piece. So I'm going to go ahead and pause the video and you choose which one is the answer. Okay, did you get it right? The answer has to be, not that one. I hope you didn't choose A because it had 2 full ones. If you did, yep, you were fooled once again. That won't work. So you've got to look closely. And what I would do certainly is probably add these up. So this one here, I have 3 pieces, 6 pieces, 6 pieces out of the 9. And then I've got another 6 pieces out of the 9, right? So I'm adding those 2. And then I've got another 6 pieces out of the 9, okay, that are shaded. Whoops! Make that 6, because only 6 are shaded. 9 are the whole. Right now, if I added 6 plus 6 plus 6, or if you know your multiples of 6, 6 times 3 is 18. But look, I've got one more. So 6 times 4, right? Because I'm adding a fourth 6. That's why we have to practice those multiplication. 6 times 6 plus 6 plus 6, or 6 times 4 is 24 over how many in each one? 9. Is that one going to work? That would be a huge negative. Nana. No, no, Millie. Cross that one off. Okay, let's look at C. So I've got a full one, right? There's my 1. I can count it like that as a single, or I can count it 9 to 9. Some friends really like to just count up all the 9s because they didn't make it into a mixed number here. The only reason I broke that down was to show you what you could do. But then by doing that, I really threw you off and you picked A. Sorry about that, guys. But let's go and erase this part here. We're going to go ahead and just count them up as the 9s. So this one's 9 over 9, so I'm going to put 9 here. Oops, I need a pen. 9 over 9, which means 1, as you can see. That's 1 whole. Then I've got a 3 out of 9, so I'm going to add 3 more to that because I'm adding, oops, make it a 9. And then I've got 7 out of 9, right? 7 out of 9. So I'm going to put that there, over 9. Okay. And then here, I've got 4 out of 9, right? So I'm adding that here. So I've got a 4 over 9. Do you notice when we're adding all of these across, right? What do you notice about the denominators? Oh, yes, I heard someone yelled out, the denominators are all the same. They have to all be the same number. In this case, it's 9. And then we just add the numerators or the pieces that were shaded. So we've got 7 and 9, real quick math, 16. And I've got an answer of 23 over 9. There's my answer. It matches that one. I've automatically showed my work, and C is the answer. All right, let's continue on to the next one with Deshawn. He drew a model of 12 fourteenths. 12 fourteenths here. So that means there are 12 fourteenths. Fourteenths is going to be my denominator, right? But of those fourteenths, only 12 are shaded in. Notice in word form, this is your denominator, and the first portion of it is your numerator. Or I could just count it up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, which means basically this is worth 1 14th, right? Each one is worth 1 14th, right? I need a skinnier pen. Okay, let's try this one. Oh, my bad. Oh, that's working like that. So this is 1 14th, right? They're all worth 1 14th, and so on, and so on, and so on. Okay, so the question is, which shows 2 correct ways? Oh, I need not 1, but I need 2 ways that I could represent 12 fourteenths as the sum. Well, again, just double check that all the all the denominators are the same. And right away I notice that all the denominators are the same. So right now, they're all candidates. Second part, I just got to figure out here's my and on each side. So do I have 12 up here and 12 over here? Well, I know 4 times 3 is 12 because I know that quick multiplication. But I do know that 6 plus 6 plus 2 is not 12. That's 14. So I'm getting rid of A. All right, I got my and, so let's go to this side. I know that 6 plus 6, because 4 and 2 equals 6, right? I know 6 plus 6 is 12. All right, put those two together real quick. But over here, I know 5 and 3 is 8, right? And then I add 8 more. 8 plus 4 more is 12. That is 12, isn't it? So I've got 12 here and 12 here. That tells me B is it, but I'm going to double check because I'm feeling like something's not right. 5 plus 5, put those together and they equal 10. 10 plus 2 more is 12. That one works. And 6 plus 6 is 12. Oh, it's already over. 7, or 5 plus 2 is 7, plus 7 is 14. Quick math, that doesn't work either. B is our answer. Clap your hands together. Now let's pat our knees. Okay, let's go to their next step. Let's see, we've got some beautiful models here. It says the model shown on the right, this is your right, represents 32 fifteenths. So I'm going to make that in a number form. 15ths is my denominator and my numerator is 32. There we go again. There we go again with a numerator larger than the denominator. It is possible because as you can see, I have two wholes here. So this would make a mixed number, wouldn't it? I'm going to put equals, and this is really something you do in 5th grade. I'm just giving you a little extra, not charging. Two wholes and 2 out of 15. That's what that is. It's a mixed number. Okay. So anyways, we want to know which model shows another way to represent the fraction. So they've coded it this way, but they want to know what's another way to do that. So there's only one way to do that. We've got to add these up. So we've got to compose them. Okay. Compose them to find out the sum. So our first picture here, model representation, I know that they're all going to be over 15. Okay, I know that for a fact. So I'm going to make my 15s here. And sum means add, so I'm putting my addition marks in between each. And then I'm going to add up the shaded area. So 3, 6, 9, 12, 13 for there. Then I've got 3, 6, 9, 10 here. Then I've got 3, 6, 7. We're looking for 32 as our answer, right? And I could put these two together and get 23 real fast because I just add 10 to 13, 23. But when I add my 7 onto that, I don't get 32. I get, put my over 15 here. I only get 30. Okay. So A can't work. Get rid of that one. Showing my work. This is what we mean. We say show your work. You're showing each option. Here we go again. We're still over 15. I'm going to go ahead and pause this. See if you can figure it out right now what the answer is. And come on back, Jack. Welcome back. Let's check your answer here. Well, if this is 12 plus 9, that does not equal 32. This is 10 plus 10 plus 10. That does not equal 32. That only equals 30. So we've got 30, 33. It's got to be C. 10 plus 10 is 20. Plus another 10 is 30. Plus 2 more is 32. C is your answer. All right, let's look at our next question. Which expression represents 9 over 7 as the sum of the fractions? Okay, so we're looking for the sum. We know that whenever we add, all the denominators must be the same. Look closely. What do you notice? Well, I'll tell you what I notice. There's 9 in the denominator on F. That can't even be possible. Our denominator has to match right away. I can eliminate that one. Now I've narrowed it down to 2. I'm going to go ahead and pause. Let me know what you think the answer is. Alrighty. Hopefully you added just the numerators easily to tell you, but we're going to show you we have to show our work, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 over there. There is 9 pieces of the 7. That tells me I got one whole one I can take out of there. Let's count these. 1, 2, 3, 4, 5, 6, 7. This is only 7 out of 7, which equals one whole piece, right? Can't be that one because we want 9 over 7. G's our answer. Dance party. All the dance parties move on. All right, let's move on here. We've got, let's see, another model here. To the right. This model represents 10 eighths. Okay, that means that my whole thing there are broke into eighths. See that? That last number tells me the bottom, tells me the denominator. So it's in eighths. But if I counted them all, 1, 2, 3, 4, 5, 6, 7, 8, I can just check to make sure 8 pieces are in that. And if I counted all the ones that were shaded, that means I would have 10, right? Okay, let's move on. We're going to figure out another way this would look. You know what to do. Show your work. Choose your answer. I'm going to finish dancing. All right, hopefully you were dancing away and you were able to figure that out, but I got D for my answer. All right, let's go ahead and look at this next one. Delaney, she drew some models below to represent 13 sixths. Okay, let's write that fraction over to the side of what this looks like. Sixths. It's my denominator. It's the second one. And what do I got on the top? 13. All right. And I've got some whole ones, that tells me. Sure do. I've got 2 whole ones out of that. So, question is, which expression shows the correct way to decompose? We're going to break it down. It means we're going to be adding these up. First of all, make sure all your denominators are, for your answer choices, are in 6, and they all are. Perfect. So from here on in, we're just adding the numerators in to see which set comes up with 13. I'm going to go ahead and pause, get your answer. Okay, looks like it's not F or G. I hope you didn't pick any one of those. I've got 12 for one of them and 15 for the other. Oh, H is 13. And 11 for the last one. So hopefully you received H on that one. You don't even know. I can make your hands clap. Hopefully you're clapping as you're getting all these correct with me. All right, Julian shaded the models below to represent 4 different decimal numbers. Whoa, we've got 4 of them, and they're all different. So we want to know which one shows these decimals least to greatest. Oh wait, we're going to have to show our work. So you know what you got to do. You got to write each one of these in decimal form. All right, go do it. And I'll listen to some music. Stars come out. Am I the only living soul around? Need to believe you could hold me down. Cause I'm in need of something good right now. We could be screaming till the sun comes out. And when we wake, we be the only sound. Get on my knees and say your friend takes round. I can make your hands clap. So hopefully you made it back in time and that you were able to go ahead and look. First thing you should have did was circle where you were going here. This was going from greatest to least. So the greatest had to be which one was most shaded. This one was. There was 10 pieces and all 10 pieces were shaded. We know that that makes a whole one. No more pieces it's all one big pizza pie. That being said, there was only one that had 1, started with 1 as being the greatest. This is 1/10. That's just one piece being shaded out of the 10. So let's move on to this next one. It says, which square below represents a whole? One whole. Which decimal number is represented by the model? Okay. I'm going to go ahead and pause this. See if you can figure this one out. All right. Which decimal number is represented by the model? Okay. Well, we know that each square represents a whole because all the pieces are filled in, right? 10 pieces, they're all filled in. 10 by 20, 10 over 10 equals 1, right? So there's 1 whole. There's another whole, 2. There's another whole, 3. There's another whole, 4. Okay, we've got 4. Do all of them, how many? Oh, that one says 5, eliminate. That one says 5, eliminate. Now how many is filled? Well, just one of the 10 pieces. Okay, so we've got 4 and a 10th, right? And I know that tens is the very first spot right after the decimals, your tens. So I would put a 1 there. That would be my answer. Does anybody know why F won't work? Well, because that's not in the tenths place. That's in the hundredths place. That's smaller. Hopefully you got that one right. All right, let's go on. Oh, it's the end. You are a rock star. And it's time. Dance away.